Hello, viewers. Welcome to the Michael Blair Virtual School. My name is Michael Blair Tatiana. I am a 15-year-old level 300 student pursuing bachelor degree in mathematics and IT. I had the privilege to complete junior high school education at age 9 and thereafter represented the Fafara Community Day Senior High School at the National Science and Maths Quiz Competition at age 11. My background, experience, and competence give me the privilege to teach you mathematics the way you will love it and excel in your mathematics examination. Let's learn together. In today's lesson, we are going to look at a topic from the Basics 9, Standard-Based Curriculum for Mathematics, or the common core mathematics curriculum basics 7, that is B9.1.2.1.2, strand 1, substrand 2, content standard 1, learning indicator 2, demonstrate the ability to determine commutative property of our operation sign. By the end of this lesson, you, the learner, should be able to 1. Explain the concept of commutative property. 2. Apply the understanding of commutative property to prove the commutativity of the 4 basic operators, which are addition, subtraction, multiplication, and division. But let's look at, first of all, what it means to say commutative property. When something is commutative, it means that no matter how you rearrange or change the positions of the things involved, you are still getting the same result. It's like if I have two oranges, if I change the positions of the orange, they are still 2. So that tells us that it doesn't matter where the positions are, you are still going to get the same and a very correct answer. This can apply to the mathematical operators: addition, subtraction, multiplication, and division. So let's test for the commutativity of these 4 operators which have been mentioned. So we'll start with the addition sign. Addition means bringing together. So let's test for 2 plus 3. So you can choose any numbers that you want to add if you want to test for commutativity of addition. So in this case, you heard me say when something is commutative, or if addition is commutative, then if I interchange the positions of the things involved in addition, it should still give me the same result. So that tells us that if addition is commutative, 2 plus 3 should be the same as, or should be equal to 3 plus 2. So 2 plus 3 should give us 5. 3 plus 2 should also give us 5. And because when we interchange the positions, we got the same answers on both sides, it should tell us that addition is commutative. If we are not sure, I will give you another privilege test for the commutativity of addition by using different numbers like 10 and 11. So 10 plus 11. If addition is commutative, then when the positions of the things involved in addition are changed, it should give us the same answer. So 10 plus 11 should give us the same answer as 11 plus 10. 10 plus 11 should give us 21. 11 plus 10 should also give us 21. And by doing this, have just proven that addition is commutative. Let's move on to subtraction. If we take two elements or two numbers like 5 minus 2. Now, if subtraction is really commutative, then that means when we change the positions of the items involved in that subtraction, we should still get the same answer. If we change the positions of the items involved in the subtraction, we should still get the same answer. So 5 minus 2 should give us the same answer as 2 minus 5. Now 5 minus 2 should give us 3. 2 minus 5. You have 2 and I'm asking you for 5. That means you have to borrow 3. So borrow in mathematics, negative 3. And 3 is not the same as negative 3. Therefore, subtraction is not commutative. Let's test again with another set of values. Let's say 11 minus 10. So if subtraction is commutative, then that means if I interchange the positions of the items involved in the subtraction, I should still get the same answer. So 11 minus 10 should be giving me the same answer as 10 minus 11 if subtraction is commutative. 10 taken from 11 will mean that 1 will be left. 11 taken from 10 will mean that negative 1 will be left. And by doing so, 1 is not equal to negative 1, and therefore subtraction is not commutative. If subtraction is not commutative, but addition is commutative, let's check for multiplication. So let's take our set of values like 5 times 3. 5 times 3. In 5 times 3, what you have to do is, if multiplication is commutative, then 5 times 3 should be the same as 3 times 5. I have something to tell you about multiplication of numbers by 5. And I think listening to it will help you a lot. Anytime you are multiplying an odd number is a number which when 2 divides it leaves a remainder which must be shared or broken into fractions. An example of such number is 3. If there are 3 objects to be shared, you realize that the first person picks, the second person picks, and there will be one left which must be broken into 2 parts or fractions. What you do is that you subtract 1 from that odd number. So 3 minus 1 should leave behind 2. So after subtracting 1, you divide that 2 by another 2 again, and that should give you 1, and you attach 5. Subtract 1, divide your answer by 2, attach 5. Subtract 1, divide your answer by 2, attach 5. So let's take another odd number like 45 times the number 5. Any number times 5 or any odd number times 5. Subtract 1. So 45 minus 1 is 44. Now divide 44 by 2. You are getting 22. And you attach 5. Sharp trick. Let's keep it in mind. Back to commutativity. You see that if multiplication is really commutative, then that means 5 times 3 should be the same as 3 times 5. So 5 times 3 should give us 15. 3 times 5 should give us 15. So because 15 is equal to 15, multiplication has just proven itself to be commutative. I'll give us another privilege to try for 10 times 11. 10 times 11 should be very easy. I also have another trick to tell you about multiplying numbers by 11. If you want to multiply a number by 11, all you have to do is you add the digits of the number. So we are multiplying 10 by 11. So we add 1 plus 0. What's the answer? 1. And you put the 1 between the digits. And that's your final answer. You are shocked, right? If I say 22 times 11, you add the digits 2 plus 2, which is 4, and you put the 4 between. And that should give you 242. So back to testing our commutativity. So if really we're saying that multiplication is commutative, then 10 multiplied by 11 should give us the same answer as 11 multiplied by 10. 10 times 11 is 110. 11 multiplied by 10 is also 110. And by doing so, you realize that both sides of the equation are equal, and therefore multiplication is commutative. We are left with our last operational sign, which is division. In division, let's try 3 divided by 1. So we are testing the commutativity of division with 3 divided by 1. So if really division is commutative, then 3 divided by 1 should be the same as 1 divided by 3. So by doing this, 3 objects divided by 1 person means that 1 person gets for the 3 objects. And 1 object being divided by 3 will mean 0.333. And 3 is not equal to 0.333. Therefore, division is not commutative. We will test our values again with the numerals 5 divided by 2 and 2 divided by 5. So in testing the commutativity of division using 5 divided by 2 and 2 divided by 5, what we have to do is that 5 divided by 2 should give us 2.5, and 2 divided by 5 should give us 0.4. So because 2.5 is not equal to 0.4, we can clearly say that division is not commutative. Let's try and solve the following 5 of them, of course. Check if they are commutative or not. Send your answers to michaelblesschool@gmail.com. Let's not forget to subscribe to this channel, hit the like button and notification bell, and comment on this video as well. Until I come your way again, it's been Michael Blair Tasiame, your favorite online tutor on the Michael Blair Virtual School. Bye for now.